All right, so we're moving on to quadratic equations. And so we'll start off with Babylonian completing the square, then we'll get into quadratic formula and some word problems. All right, so I'm just going to kind of walk you through it. It's an algorithmic approach. When we have quadratic equations in this form, x squared plus bx equals c, we can solve using their technique of completing the square. They only work with positive numbers, so because they were using it for geometric purposes, so negative values wouldn't have any meaning for them, right? So even though when you take the square root of a number, you get negative and positive results, we're going to disregard the negatives for this, which many people might find to be a good thing, because that's the most common error when it comes to completing the square, is forgetting to account for the negative solution. So to solve, the first thing you do, assuming that it's in the right form, the first thing you would do would be to calculate b over 2 squared. All right. If it's not in the appropriate form, then put it in the appropriate form first. Once you calculate that b over 2 squared, you're going to add it to both sides. You're going to factor the left-hand side and simplify the right-hand side. Right? The factors will follow this relationship. Right? So maybe factoring polynomials wasn't a strong suit for you, but if I tell you that whatever the value is that's getting squared, that b over 2, that's going to be the term of the factor that makes it all work, and then you're going to be in pretty good shape. So it's really just a matter of getting a hold of that b over 2 and then using that in this formula, if you want to think of it as a formula. All right. So I'll show you the solution to this problem: x squared plus 2x equals 15, using this technique. So x squared plus 2x equals 15. All right, so that is example 1. All right, so when I write this, and I'm not the only one, but I tend to write it with a little space to complete the square. So I'll rewrite it: x squared plus 2x, leave a little space to complete the square, is equal to 15. All right, the b value is the coefficient of x. The c value is that standalone constant. So we compute b over 2 squared. All right. So 2 over 2 squared, which is 1 squared. All right, which is just a 1. All right, so my b over 2, I'll make a little note of this. My b over 2 is equal to 1. And as it turns out, b over 2 squared is also equal to 1, because 1 squared is 1. All right, so if our rule tells us, and I'll just kind of jot it on the side here, we had x squared plus bx equals c. If it's telling us that this is going to be equivalent to just writing it. Yeah. This expression is going to be equivalent to the original equation. This new equation is going to be equivalent to the original equation, but have a perfect value for the c term, or this third term in my polynomial, to allow us to take the square root of both sides of the equation, then mission accomplished. All right, that's the whole point behind this. All right, so this ends up being x plus b over 2 squared is equal to all of this stuff. All right, so in my formula, or my approach here, my example, I would write this as x squared plus 2x plus 1 is equal to 15 plus 1. All right, that's, let me use my highlighter here. That's this guy getting popped in. All right, then that factors to x plus 1 squared, and that's equal to 16. So that's this one. Then we would take the square root of both sides of the equation, only accounting for the positive. So that's going to give me an x plus 1, because the root and the power of 2 offset each other. The square root of 16 is going to be a 4. All right. And then once you do that, you solve for x. All right. So in this case, using the linear algorithm from the last unit, I would subtract a 1 from both sides. X equals 3. All right. So that's the complete solution. Now you can see it's all typed up. It looks like a lot, but if you kind of cut a lot of the fluff out, it gets a lot easier. So I'll do example 2, x squared plus 6x equals 40. This time I'll leave the space initially. I'm going to take my b value. So b over 2 squared is going to be 6 over 2 squared, which is 9. So add 9 to both sides. The left-hand side is going to factor. It's going to become x plus 3, because my b over 2 is 6 over 2, which is 3. Squared is equal to 49. Root both sides. X plus 3 is equal to that principal square root of 7. Then subtract the 3. And that would be it. All right, x equals 4. And I can compare that with the solution. And there you go. In a separate video, I'll do the geometric approach. It's an optional topic, so it's not something that I would put on a quiz or an exam. So we'll hold off on that. But you should be able to handle those questions in the section examples or practice problems.